on this computer. Okay, great. So we have to finish going through the introduction to simple experiments. And then I think I might want to jump into results because I do talk about some of the common mistakes I found through the paper. And then we can go through the method if we have enough time. If not, we can go over it next Monday. The results section should be pretty straightforward for y'all to write, especially I gave you like some guidance, or I wrote some guidance today, this morning. So it should be helpful. So let's go through experiments. So we've talked a little bit about what experiments are. So can anyone just tell me really briefly what the difference is between an experiment and a correlational study? I don't think we've talked about this explicitly, but this is something that I do want to go over when we talk about results.
The way I understand it is that a correlation study is simply discovering whether or not there is a relationship between two variables, and an experiment goes more in depth and examines like why that relationship exists.
Yeah, so you can establish causation. And do you know about what is it about the research design that lets you establish causality with an experiment versus a correlational study? If you don't know, that's okay. I'll go over it.
Yeah, I don't know.
Okay, so correlational study, you just essentially measure two variables. So you measure, you can measure people's height and people's weight, measure two variables, but you're not saying that the height causes the weight or the weight causes the height. In an experiment, you typically have an independent variable, at least one, frequently multiple. And within that independent variable, you have multiple levels. So let me actually skip back to the results section and then we'll pop back here. Because I think this is important to discuss too. Slideshow from current slide, from beginning. All right, so I'm just going to skip through. So I'm just going to go through the first few slides. So this is a common problem with the papers that I've been reading. And I think it might be because I haven't been explicit in what an experiment is and that an experiment is required for these papers. So I didn't dock points because of that. But a lot of you wrote that you're exploring the relationship between X and Y, which is fine, but that's a correlational study. So you must conduct an experiment. And what's an experiment? It's usually random assignment to one of X conditions. So you can have multiple conditions and you measure a dependent variables. Some of you, like Alacia, might be conducting a quasi-experiment, which is still valid. And that's when you separate groups into already naturally existing groups. So for instance, Alacia is investigating how whether introversion versus extroversion predicts differences in symptomology related to anxiety. So it wouldn't be ethical for her to randomly assign people to be introverts or extroverts. So what she can do is already get people that are already pre-existing within those groups. So that's why it's a quasi-experiment. And again, after she separates these groups, then she can measure her dependent variable. Cool. Does that make sense, Alacia, for your experiment?
Yes.
Okay, great. So those are already pre-existing groups. You don't have to randomly assign, but that's fine for this class. So this is someone, I said I wasn't going to talk about whose studies these were. All right, so this is another student in our class. They have an actual experiment. So they have a random assignment to one of X conditions. So this person has one independent variable with two levels. The two levels means that there are two different conditions that participants can be separated into. Now I named this independent variable time of reporting loneliness. This is what it should say, loneliness, my bad. And they want to tell people, can you report your loneliness either pre-COVID or during COVID? So the independent variable here is the time. And then they complete the dependent variable, which is the loneliness scale. So I also went through and sort of created a diagram So for the actual experiment, the person who's doing an assessment of loneliness, either pre-COVID or during COVID. So participants arrive and they're randomly assigned to either read a paper that says you're going to tell me about your experiences pre-COVID, or you're randomly assigned to report your experiences during COVID. After you read that piece of paper, you complete the loneliness scale with either pre-COVID or during COVID in mind. So this is the independent variable, 2 levels, and this is the dependent variable. If you wanted that in words, if it's easier for you, sometimes it's easier for me. Participant 1 arrives to experiment. They read a paper that says that they will be evaluating their sense of loneliness pre-COVID, so they're assigned to the pre-COVID condition, and then they complete the loneliness scale. Participant 2 would arrive to the experiment. They're randomly assigned to rate their loneliness post-COVID. So they read a paper that says that they will be evaluating their sense of loneliness post-COVID. And then, so of course it's not December 2019, I should erase that, but the dependent variable is loneliness scale. So the only thing that differs is whether they get assigned to the pre-COVID or, sorry, during COVID condition. Does that make sense?
Yeah.
Okay. So if this person wanted to do a correlational study, they would just track people across time and continuously measure their sense of loneliness. So you could correlate time with loneliness. But by randomly assigning people to either pre or during COVID, that is what makes it an experiment. So you can compare the differences. And that way you can say the time of reporting is what causes the loneliness to be different. So for the quasi-experiment, the question is, do introverts versus extroverts display different anxiety symptoms? So we can't randomly assign people. So what we do is we have them complete an extroversion scale. I think this is how you measure introversion versus extroversion from what I've read. If they score low on extroversion, then they're naturally introverts. If they score high on extroversion, then they're naturally extroverts. So you're not randomly assigning them to condition, but you're measuring and then assigning them to groups based on their natural scores. After that, you measure their anxiety symptomology. That's your dependent variable. So for participant 1, for instance, they complete the measure of extroversion. They naturally score low on extroversion. Thus, they are an introvert. That's their independent variable. And they complete the scale of anxiety. Participant 2 completes a measure of extroversion. They naturally score high on extroversion. Thus, they are classified as an extrovert, and they complete a scale of anxiety symptoms. Is that clear? Like the difference between an actual experiment and a quasi-experiment. So for this class and this paper, I do want you to either randomly assign people to condition or separate people into already pre-existing groups. So you could see another study might be, is there a difference between male and females in how much they like hot Cheetos or whatever the case may be. I think I'm just going to jump into this presentation because it feels like it makes a little bit more sense. And then we can go back to the other one. Another problem with papers, this hasn't really come up, but I anticipate it might come up when you submit the method section, is you might be wondering, well, how do I measure anxiety, or how do I measure loneliness, or how do I measure, Haley, what are you measuring? Attitudes.
Harmful workplace experiences.
Yeah,
sexism
like
at work.
Yeah, so sexism in the workplace. Well, you have the benefit of having hundreds of years of research in psychology. So people have already created these scales. So when you go on Google Scholar, PsycInfo, you can just look up anxiety scales, or you can look up loneliness scales, or I know, Haley, you've already looked up sexism scales. So people have already created these scales. Your job as a student in this class is mostly writing the paper, which involves learning APA mechanics and designing a study. So knowing what your independent and dependent variables are. That's the hardest heavy lifting that you'll be doing. The rest of the things, the independent variable and the dependent variable, should be relatively easy because research has already done a lot of the work for you. Is that clear?
Mm.
Okay, cool. I think I will stop here and we'll talk about anticipated results shortly after. But I did want to clarify what the difference was between an experiment and a correlational study. Because it was so common, it made me feel like maybe I didn't explain it thoroughly. So I just wanted to review it. Okay, so in your own words, Haley, how would you make your study experiment versus a correlational study?
Well, mine is like I'm gonna be asking the women, I'm gonna be putting them into like two groups, basically, like recall a positive experience from work or recall like an experience where you were like in like a harmful workplace experience, so like being harassed or sexually harassed. And I feel like that would be an experiment. But if I was to look at correlational, I could look at how being a woman relates to getting sexually harassed at work, I think.
Yeah, so you would just look at, you collect data from men and women and just have them report how much sexual harassment you experience and correlate it.
Yeah, okay.
The other study, the first experimental study that you were talking about, will you only recruit women?
Oh, well, actually, I'm going to be recruiting men and women, but I just, yeah.
And then you also will be recruiting different age groups, right?
Yes, I have like 20 to 45 and then 45 plus.
Cool. So there you have two independent variables. One is sex, men or women, or female or male. And the second independent variable is age. But for both of those, you can't really randomly assign people to either sex. You can't really randomly assign people to be either age. So that will be a quasi experiment because you're letting people sort of rest in their naturally existing groups.
Okay.
Yeah. Is that clear? Does anyone want to do this with
Yes.
their study? Talk about how it could be different in a correlation versus an experiment.
Maybe me,
Okay.
because I definitely think that I did. I think in my introduction, I definitely phrased it the wrong way. So
Okay. Go for it.
couldn't I, so going back to the quasi experiment, could I do that one for mine? Do you remember what mine is? The correlate, not the correlation, what would be the word that I would use?
So seeing whether, what's your independent variable?
Mental health and social media are like
Oh,
really
okay.
together.
Yeah, seeing whether social media use influences mental health,
Okay.
and how are you operationalizing social media use? So that has to be an independent variable.
Yeah. Because I was just gonna do a online quiz and like group them, like so I could have like the people who use a lot of social media versus people who don't use a lot of social media.
Perfect. Yeah,
Now,
so that's
doing it in like time increments instead of like variations in social media.
okay, perfect. Yeah, so your independent variable would be time spent on social media. You're talking about using already pre-existing groups. So they either use a lot of social media or spend a lot of time on social media versus not a lot of time in social media. And then your dependent variable is mental health.
Okay.
Would it help if I wrote that on the PowerPoint?
I don't think so.
Okay.
Got it. Thank you.
Okay. Perfect. Yeah. So, and how would you make that a correlational study?
I'm not quite sure yet.
So instead of grouping people into low or high, you would just run time spent on social media as a continuous variable. So it could be from 0 to however many hours in a week there are, and relate that to their depression scales. But the fact that you're creating these groups and putting people into these groups sort of makes it a quasi experiment and makes it so that you can run different data analysis techniques that we'll talk about.
Okay, sounds good. Thank you.
Cool. Yeah. Anyone else, or do we got it? We got it? Okay, cool. All right, we talked about taking notes and eating pasta. Does anyone want to talk to me about those studies?
I just spent the morning looking at all the pasta stuff.
It doesn't sound good right now.
No, I mean all the examples of the
Uh-huh.
bowls of pasta, control variables and things.
Yeah, so what were they looking at in that study?
Well, okay. I just went over a lot of stuff, but they're looking. Independent variable is the size of the bowls. Two different size bowls, and participants are assigned one bowl or the other bowl. They go in and they get served, and so the dependent variable is how much they can serve themselves. So depending on the bowl, they're checking the calorie intake between the two groups. And the large bowl people and the medium bowl people.
Yeah, and they found differences, right? And what
And
makes
they
it
found differences, yeah.
and what makes it an experiment is that they randomly assign people to either get a medium or a large bowl. So that is perfect. So that's the difference between the independent variable, which was the size of the bowl, versus the dependent variables, which was how much pasta they served themselves in grams, and the calories that they consumed. Great. Just to remind you of experiments. All right, we talked about independent variables. So those variables are manipulated. Sometimes they are measured, right? So for you that are doing quasi-experiment, and then the dependent variable are usually what's measured or the outcome variable. And then I think we went over this briefly about why experiments support causal claims. So I would try to remember this. This is another reason why experiments can and are better than correlational studies, because they establish causality. And it's because of these three factors. They establish covariance, they establish temporal precedence, and they establish internal validity. So what is covariance? This is just reviewing what we went over Monday.
I think I'm still struggling with the understanding the definition of it.
Okay.
It's like, do the results show that the variables are correlated?
Yes. Or do the variables show a relationship? Is there a relationship between the independent and dependent variable? So that is a factor that is found in a correlational study. So that's something that is in common with correlational studies and experiments. What about temporal precedence? Experiments establish temporal precedence. What does temporal sound like?
Time.
Time. Okay. So what does precedence sound like? Not presidents, but precedence.
Like first.
Yeah. So it establishes time order. Temporal precedence means it establishes time order. So by running an experiment, you can say X happened before Y. So for instance, for the student who is, can I just say who's doing the COVID study? Okay, Rick. It's just harder to talk about it. Okay, so Rick's doing the COVID study, and he is randomly assigning participants to either pre or during COVID first, and then he's measuring depression, right? He's not measuring depression and then telling people, okay, well, tell me about your experiences pre-COVID, or tell me about your experiences during COVID. So what that means is that you establish that the time that people are primed with leads to different scores on depression or loneliness. In a correlational study, you wouldn't be able to tell whether X came before Y or Y came before X. So for something like Alessia's study, you wouldn't be able to tell whether the anxiety symptoms came first and then that led to different personalities, or whether personalities came first and then that led to different anxiety symptoms. So experiments are have one up on correlational claims because they establish temporal precedence or time order, whereas correlational studies do not. What about internal validity?
This one's like if there's a third variable that could be associated with the other two variables.
Exactly, yes. So well-designed experiments establish internal validity. So what this means is that you try to limit any other variables that could influence the results. So for instance, in the PASTA study, they might have recruited people at different times of the day so that they could eliminate hunger or lunchtime or dinner time as a reason for eating more or less. So they could establish that eating more or less was a result of bowl size and not these other variables. And Alacia, I think this is something that you brought up last class. You asked whether this is why they control so many variables in a study, right? So this is about internal validity. Yes, when we run experiments, and I talked about the Claire effect. So we try to keep everything consistent so that no other variables, including our research assistants or time or temperature or the color of the bowls, might affect our results. So we can say with more certainty that it's that our results are due to our manipulation of the independent variable and not the dependent, not the dependent. We can say our manipulation is the result, is what causes the dependent variable and not any other thing in the environment. Was that clear? There was a little bit of a hiccup there, but is that good? Okay. All right, so again, covariance, relationship, temporal precedence, time order. Does X cause Y or Y cause X? We establish the order by saying the IV comes first and then the DV. And internal validity, we try to control for all other variables. Another way that we establish internal validity is through random assignment. So what's random assignment? So we have random sampling and then we have random assignment. So give me a definition of either, and then we'll go from there.
Picking numbers from a hat.
Is what?
Random.
It is random. Is it random assignment
It's
or random
random.
sampling?
Oh, good question. It's very random. It's random assignment.
Okay, so you pick numbers from a hat, and then what do you do with the numbers?
Okay, bad example. I didn't know what.
No, it's a good example. I think so.
A number. So there's two different. So there's yes or no in there, and that's how people get into two different groups. It's,
Perfect.
they pick
Can
it
we-
out of a hat.
Perfect. So can we use your study as an example?
Sure.
How many independent variables do you have?
Well, there's two. There's pre and during COVID.
So there's one independent variable, which is time,
Time. Oh, time.
but there's two levels. So it's pre and during.
Okay, two levels of the independent variable.
So then what you would put in the hat or in an Excel sheet, for instance, like we did one of these classes, is you would put an equal number of ones and an equal number of twos. Let's say you want 100 participants, you would have 50 ones, 50 twos, and then you would pull the numbers out, and Alacia's name comes out first. She gets randomly assigned to pre-COVID. And then you get my name, and I randomly assigned to pre-COVID. And then you get Alejandra's name, and she gets assigned to during COVID. Get Haley's name, she gets assigned to pre-COVID. So by pulling those the numbers in the hat are the conditions, and the pulling of the numbers without any systematic like choosing of the numbers is random assignment. You're separating students into conditions arbitrarily. So that's random assignment. What about random sampling? You also can use a hat, but you're going to need a pretty big hat. And the numbers in the hat are different. Anyone else?
Yeah, someone else.
Yeah, I don't want to put all the pressure on you, Rick.
So for mine, it would be the independent variable is personality, and then the levels within it are, well, no, I'm not doing random assignment, so mine wouldn't count.
Yes, so we talked about random assignment. So this is what happens before random assignment. So it's kind of when we're thinking about the design of the experiment.
Isn't it like the treatment group versus control group.
No, that's kind of the random assignment. Anyone else? Is it helpful to ask these questions? I'm just trying to
Yes.
tie it all
Yeah.
together. Okay, I'm just trying to tie it all together. Okay, so I like pictures.
Yeah, pictures are good.
Okay. Oh, I need to Google something. Hold on. So I'm just trying to put it all together so like it makes sense why we're even talking about. Okay, this is a cute picture. I swear this is for educational purposes. Okay, save image as desktop. It is going to be named hat. And I'll save this. Random sampling or random assignment, who knows? Okay, so I'm gonna insert a picture from this device. Here we go. We have a hat. Let's pretend this hat is upside down. We talked about, let's see. So, yeah. So we talked about random assignment. And that's where put numbers in a hat that correspond to your levels of independent variables. So it could be, for example, it could be you put ones for pre-COVID, twos for during COVID. And I think, Grace, you said control, right? Did you say that? Okay. Another example might be you have 0 for control, 1 for experimental manipulation, and then 2 might be like a placebo. So when you pick these numbers out of the hat, the number corresponds to what condition the participant will be placed in. But before that, so I'm going to copy. Comes random sampling. So random assignment comes when you already figure out, okay, I want to do a study on X, and my population, hint, hint, will be WU students.
So you want to narrow it down to a representative smaller group of that larger group of students.
Yeah. So let's say that in the hat, you have this giant hat, and in the hat, you have your population of interest is WU students. But of course, you can't possibly ask everyone to complete a survey. One, because it's going to be costly, time intensive. People don't check their emails. People have so much work to do that they're not going to complete the survey. So you want to get a representative sample. So what you do is in this huge hat that you have, I think we have like 4,000 or 5,000 students. There are 5,000 names, but you say, I only want 100 students. So you're going to pull 100 names out of the hat. Each name has an equal probability of being pulled from the hat. So you get your research assistant, you print out a list of names and they cut all the different names. So you have 500 or 5,000 sheets of paper, and then you randomly pull out 100 names.
Excellent.
And what that allows for is generalizability. Pull.
Generalizability, the sample group relates to the bigger group.
Yes. So
the group that you're looking to represent
can be generalized to population. So let's say most people at WU for your samples say that they prefer Coke to Pepsi. Then you can assume, do all of you prefer Coke to Pepsi?
No.
No? Really? You prefer Pepsi, Rick? Oh, man.
Got
Okay,
more
let's say
food.
that of the 100 students, they all like Pepsi. And if you randomly sampled them from the population at WU, you can assume the entire population at WU prefers Pepsi, thus we need Pepsi machines. I like Diet Coke. Okay, so that's random sampling. And this allows for, what is the purpose of random sampling? Allows for generalizability. I swear this has a meaning behind it. Okay, so now let's go back to random assignment. That's what we were talking about. So what is the purpose of random assignment?
It helps with internal validity.
Helps with internal validity, how?
It ensures that like the comparison group and like the treatment group, I guess, have like the same kinds of people in them. Like, so there's no like alternative explanations for the results, I think.
Yeah. So for instance, if we're doing Pepsi versus Coke, it would be people, let's say for some reason that Coke drinkers, not Coke doers, but Coke drinkers experience more loneliness generally, right?
Oh, it's very sad.
Versus Pepsi drinkers. So what Rick would want to do is by randomly assigning participants to condition, he can ensure that people in the pre-COVID and during COVID condition, there are an equal number of Pepsi and Coke drinkers in each. So that way, if there are differences on the loneliness scale, you can't attribute it to them, the third variable of them drinking Coke or Pepsi, but instead you can attribute it to the conditions. Does that make sense?
Yes.
Definitely want to establish causation.
Yeah, you want to establish causality because let's say you find out that you have more Coke drinkers in the COVID condition, more Coke drinkers, and pre-COVID you have more Pepsi drinkers who experience less loneliness. And your hypothesis, which I think is your hypothesis. Okay, I might need. Okay, I'm just going to copy this so that. Is this helpful, putting all of this together?
Mm-hmm.
Yes, okay. Okay. All right, so you find that hypotheses are supported. People report more loneliness in the during COVID condition relative to the pre-COVID condition. Your takeaway from this is that time of reporting causes loneliness scores to increase or decrease. But I, a researcher that does research on Pepsi versus Coke, know that Coke drinkers experience more loneliness. And I heard you say that there were more Coke drinkers in the during condition. So I would say, wait, it might not be your conditions, but it might actually be the fact that you have more Coke drinkers in the during condition that led to more loneliness. So that would decrease your internal validity. But when you do random assignment, you have an equal likelihood of putting people that are Coke drinkers versus Pepsi drinkers in either condition, which eliminates what kind of beverage they like to drink as an explanation for the relationship between time and loneliness. That's a lot. Does that make sense?
Yes.
Yeah. Grace and Haley.
Yeah.
Okay. So yeah, sorry, go ahead. I think someone was speaking. No?
Not me.
Anyone have a question? It's totally fine. This is a lot to throw at you. No?
That's very helpful. The random assignment things were just, Hammer it into my brain. I'm understanding now.
Yeah. And it sometimes the problem I had with classes when I took classes is like, you just throw all this information at me and I don't know how it all fits together, but I'm trying to like scaffold it so that it makes sense. Why are we talking about random assignment? Why are we talking about random sampling? But hopefully now it makes sense. And you'll remember the little, this is literally the first image I got when I Googled hat. Cartoon frog design bucket hat. So cool. All right, we're clear there. And essentially the point I was trying to get across, I think Haley, you answered it. Random assignment helps with internal validity. So it helps you say that your independent variable is what caused the dependent variable. Oof. Okay, we talked about temporal precedence and all that. Ooh, I don't think we talked about this. Okay, so now we're gonna go back and I'll keep the little froggies and then I'll update the slides online. Okay, so design confounds. So sometimes there's a confound within your experimental design. So the study on note-taking, if all the students in the laptop group had to answer more difficult essay questions than those in the longhand group, that would be a design confound. If you had more people drinking Coke in the during COVID group than in the pre-COVID group, that would be a design confound. So it's when a second variable varies systematically along with the independent variable and provides an alternative explanation for the results. So it's not that time affects loneliness, it's that there are more COVID drinkers, there are more Coke drinkers in the during COVID condition than in the pre-COVID condition. So systematic variability is the problem. Systematic means that Coke drinkers are more likely to be in one condition versus the other, but sometimes there is unsystematic variability. So this is random or haphazard and affects both groups. This isn't a confound. So having more Coke drinkers in either group could be systematic or it could be unsystematic. So let's say that Rick Tingle was a professor and he was trying to get funding from Pepsi because he loves Pepsi and he wants free Pepsi to deliver to his house. And he wants to show that Coke drinkers and people that are reporting loneliness during COVID experience more loneliness relative to those that are reporting during COVID. So you send everyone a survey before they participate in your study, and you ask them what kind of drink they like best, Pepsi or Coke. And then once you know that they like Coke, you throw more Coke drinkers in the in the during COVID condition, and you throw more Pepsi drinkers in the pre-COVID condition so that your results are supported. So then you can say people report more loneliness when they are asked to report loneliness during COVID relative to pre-COVID. And we also find that Coke drinkers are more lonely. Thus, if you want to experience less loneliness, you should drink Pepsi. Yeah, so that's the systematic variability. It's like when the person who's conducting the research loads one condition more with a population of interest that can support their hypotheses versus another. Unsystematic variability is Rick has no idea that Coke is related, but somehow he has a research assistant who's like, oh, I read this paper that says Coke drinkers are more lonely. So you add a question about whether people drink Coke or Pepsi more often into the survey. And after you randomly assign people to condition, you might find that there are more Coke drinkers in the during COVID condition versus the pre-COVID condition. And that's what leads to your results. So this is more haphazard or random, but you could still report your results. This is more ethical to report your results. You might say a limitation is that we had more Coke drinkers in the during COVID condition, so we can't untangle whether the COVID drinkers affected loneliness or whether it was really reporting during COVID. Our manipulation of the independent variable. Future studies should only recruit water drinkers because they're experiencing a wide range of loneliness.
So the systematic is like deliberately making it so your hypothesis is supported, whereas the unsystematic is you just happen to know there's another possible variable.
Yeah. And sometimes we do that too. So what I mean, we do that too, is that we have unsystematic variability. So we know that there's a variable that might also coexist with our manipulation. So we try to collect data on that at the very end of the study to test whether, so let's say we're conducting a t-test, which is a difference between two levels of an independent variable. So we might run the analysis, like for Rick's study, we want to see a difference between the pre-COVID and during COVID on loneliness. So we're going to run that analysis. We find that people that are in the pre-COVID condition experience less loneliness than those in the COVID condition. Great. But Rick also collected data about Coke drinkers and Pepsi drinkers. So then you would use that variable as an independent variable. So now you're going to test whether loneliness varies as a function of drinking Pepsi or Coke. And then if you find that loneliness does vary as a function of drinking Pepsi or Coke, and then you also looked at your conditions and see that there are more Coke drinkers in the during COVID condition, then that gives you more information that lets you know that your independent variable might have not predicted the difference as much as this third variable. Does that make sense? Alicia?
Mhm.
Okay, are you sure?
Yeah.
It's a lot. I'm throwing a lot at you.
I relate all of them really good to the bowl of spaghetti again.
Okay, yeah.
They used an example of the servers for systematic. If one of the servers decides to treat the people in the big bowls nicer or something like this, then it would be systematic. But unsystematic, as if that same server was just randomly sentimental for both groups.
Or randomly had mood swings. So sometimes they were really
Yeah.
happy and sometimes they were upset. Yeah. Yeah, that's another good example. Is that clear? Yeah. Okay.
Yeah.
All right. There are also selection effects. So what's a selection effect? So this is when participants in one level of the independent variable are systematically different than the participants in the other level or levels of the IV. So this could happen if I told you as a participant in the study, hey, you can either choose a medium bowl or a large bowl, and you're really hungry. So you're like, I want the large bowl. So we have self-selection effects where people actually assign themselves to condition, and then that would support the hypothesis. So if I'm really hungry and I get the large bowl, I'm going to eat more. I'm going to serve myself more. Another example from the textbook is the Lovas 1987 study, where they tested treatment for autism. So they had intensive therapy for children with autism. So some children in the study received the new treatment and others continued the usual treatment. So however, they weren't randomly assigned to these groups because some families lived too far away from the intensive treatment and other families requested the intensive treatment. So some people self-selected to get the intensive treatment. So the researchers found that the autistic symptoms of children in the intensive treatment group showed more improvement here than those who continued with their treatment as usual. But because they weren't randomly assigned, we can't say that the manipulation of intensive treatment versus treatment as usual is what caused the improvement. Because of the selection effect of the families, them choosing whether they wanted the intensive or their treatment as usual. So there were systematic differences in what condition they were assigned. So you can avoid these selection effects, again, with random assignment. No matter how far away people live, you might provide them with bus vouchers or Lyft credits or something to make sure that enough people that live far away and close get the intensive treatment. Enough people that live far away or close are also in the treatment as usual condition. So that's random assignment is a way of assigning participants to levels of the independent variable such that participants have an equal chance of being in each group. There aren't any distance variables. There aren't any money variables that might influence the results. So there should be no systematic differences between the groups with random assignment. So that's what it helps, establishes internal validity. You can also avoid selection effects with matched groups, because random assignment mathematically should work, but we know in the real world it doesn't always work, particularly if your sample is small. So some researchers prefer to use matched groups with small samples. So if you have participants with a high GPA, you might pair group 1 and group 2. So group 1 is the pre-COVID group, group 2 is a during COVID group. So make sure to have enough people, an equal number of people with high GPA, next highest and lowest GPA. So that way you are ensuring as experimenter, you have enough people throughout the GPA spectrum within each condition. So this is you sort of ensuring that there are an equal number of people that share an individual difference factor that you think might affect the dependent variable in each condition that you're interested in. So matching involves matching groups on some variable, and we randomly assign 3 participants with the highest IQs to 3 groups, then assign the next 3 participants, and so on and so forth. Okay. All right, so what about independent groups designs and within groups designs? So this is, the independent groups designs is mostly what all of you will be running or talking about in your papers. We'll talk about post-test only design, pre-test, post-test, and which design is better. So we've talked about why experiments might be better, temporal precedence, internal validity, and establishing causality, having covariance. And now we're going to talk about particular experimental designs. So these are actual experimental designs. So the independent groups design is also known as a between subjects design or a between groups design. So what this means is that different groups of participants are placed at different levels of the IV. So an example that we've already talked about is that participants were randomly assigned to either a medium bowl or a large bowl condition. Within the independent samples groups design, there is post-test only and pre-test post-test design. And we'll talk about that on the next slide. Within groups design, on the other hand, is also known as within subjects design. So this is when each participant is presented with all levels of the independent variable. So this would be if on day 1, participants were randomly assigned to get the medium or the large bowl, and on day 2, they got the opposite bowl. So they are assigned to each level in the independent variable. Another example would be if you conducted a note-taking study and each participant engaged in both the longhand and then did the laptop condition. And the difference here, apart from assigning people to different levels of the IV or the same levels, is the comparison group. So with independent groups designs, you're comparing group A to group B. And within groups design, you're comparing the person to themselves across time. And I'll explain that in the next few slides. Okay, so this is a post-test only design, and this is for independent samples. And this is sort of what most of you will be doing, or most of you have been talking about doing. So first, you randomly assign people to either group 1 or group 2. So pre-COVID, during COVID, and you measure the dependent variable, kind of like the thing that I drew earlier. So an example from the text, you randomly assign people to either take notes on a laptop, take notes via longhand, and then they complete a comprehension test. So the dependent variable stays the same for both groups. The only thing that differs is the independent variable. So participants are randomly assigned to an independent variable, and then they complete the same dependent variable. And they're tested on the dependent variable just once. A pre-test, post-test design is more of a within subjects design. All right, so people are randomly assigned to one of 2 groups, and they are asked to complete the dependent variable twice. So participants are randomly assigned to at least 2 different groups and are tested on the key dependent variable twice, one before and once after completing exposure to the independent variable. So this graph or this picture is representing a study that you read about in chapter 1 on mindfulness training. So in this study, 48 students were randomly assigned to participate in either a 2-week mindfulness class or a 2-week nutrition class. And 1 week before starting their respective classes, all students completed a GRE score or a GRE test, a verbal GRE section. Do y'all know what the GRE is? It's like the SAT, but so the SAT usually take it to get into college. The GRE is the graduate record exam. So it's like the SAT, but for grad school. So 1 week before starting their classes, all students completed the verbal section of the GRE. And 1 week after the classes ended, they completed the GRE score again. All right, so people are randomly assigned to either mindfulness class or nutrition class. Before taking either class, we get a baseline score of their verbal GRE. And then after they participate in the class, which is the independent variable, they take the GRE again. So here we have the people that were in the nutrition class versus the mindfulness class. We have accuracy on the verbal GRE. You can also think of it as doing well on the GRE. Higher scores means you did better on the GRE. And then the light bars are pre-test. So here, the dark bars are post-test here. So you can see in the nutrition condition, it seems like participants might have done slightly better in the pre-test relative to the post-test condition. So the nutrition class didn't necessarily cause them to improve. But in the mindfulness condition, what you see is that participants had higher post-test GRE scores relative to the pre-test. So you can see the change that resulted as a function of the type of class that they took. Does that make sense? So here you're comparing scores before and after within the same group. All right, so which design is better? The situation, like most things, determines which design is better. In some situations, it's problematic to use the pre-test and post-test design. So let's say that you want to see whether the size of the bowl influences eating. So you have people and you want to compare what people normally eat to what they would eat after they got the different size bowl. So you bring participants in and you tell them it's going to be a 2-hour study. So in the first half hour, you just let them eat as much as they'd like in a bowl that is of normal size. And that way you can measure how much people eat usually. And then you assign them to a medium or a large bowl condition and have them eat again. So that would be problematic to use a pre-test and post-test design because people probably already stuffed themselves with food beforehand. So you might not get a significant result. Another dependent variable that might not be good to use a pre-test and a post-test design for would be physical exertion, how much you or how fast you run after having Gatorade or water. So first we have people run a mile, and these regular people run a mile, and then we have them drink Gatorade or water, and then we have them run a mile again. So of course, running 2 consecutive miles for most people that aren't in really great shape, including myself, would be really hard. So for the first mile, I might walk part of the second mile. So the reason why a pre-test, post-test wouldn't be good in this instance is that participants might become full or exhausted by having a pre-test, post-test. Sometimes we also don't like using a pre-test, post-test when we're looking at GRE scores because you become familiar with the kind of questions that are asked. But in the study that we just talked about, it was okay because there was a 2-week period between when they took the pre, they took the class, and then they took the post score again. Post-test designs sometimes, so in other situations, pre-test, post-test designs make sense. A lot of people use that pre-test, post-test design with interventions. So some people that study prejudice and discrimination might measure how racist people are at time 1, and then assign some people to watch a lot of films with diverse characters or watch regular Disney movies and see whether watching movies with diverse characters reduces people's prejudice. So in that case, a pre-test, post-test design might be good because you want to see whether the intervention, which is watching films with diverse characters, can reduce racism. Post-test only designs can still be very powerful. So most of you are conducting post-test only designs. So I wouldn't worry about the power there. So they are powerful because of their combination of random assignment and a manipulated variable. But if you want to make sure that the groups are equivalent at the start, you're going to need a pretest. So random assignment and manipulated variables make it so that mathematically they should be relatively equal, but sometimes they're not. And if you want them to be equal with 100% certainty, you would use a pretest. All right, so within groups designs, so there are concurrent measures designs, repeated measures designs. We're going to talk about the advantages of within groups designs, covariance, temporal precedence, and internal validity in within groups designs, disadvantages of within groups designs, and whether pretest and post-test is a within groups design. All right, so let's talk about repeated measures. So repeated measures means that participants are measured on the dependent variable more than once after being exposed to each level of the independent variable. So this study is pretty fun. So researchers Erica Boothby and her colleagues used a repeated measures design to investigate whether a shared experience would be intensified even when people don't interact with the other person. So they recruited 23 college women to a lab. Each participant was joined by a female confederate. So confederate, again, is someone who's in on the experiment, but the actual participant doesn't necessarily know that this person is in on the experiment. So these two women sat side by side facing forward and never spoke to one another. So the participant was told that the two chocolates were different, but in fact, they were exactly the same. After tasting each chocolate, participants rated how much they liked it. The results showed that people liked the chocolate more when the confederate was also tasting it. So all people are in one group. They taste the chocolate when they are sitting side by side with a stranger. They rate the chocolate, and then the stranger leaves. They taste the chocolate alone, and they rate the chocolate. So as you can see, those who were in the shared experience first, they liked the chocolate a lot more versus the unshared experience, even though it was the same chocolate. So their hypotheses were supported. People tend to like things more when it's a shared experience. So repeated measures just means that people complete the DV twice after being exposed to all levels of the independent variable. Independent variable was tasting chocolate alone or with someone else. Dependent variable is rating chocolate. What about concurrent measures design? So this is when participants are exposed to all levels of the independent variable at about the same time, and a single preference is the dependent variable. So this is a good example of this is infant research. So of course, infants can't talk to us and tell us what they like, but one way that psychologists who do research on infants establish liking is by how much time you spend looking at something. So looking preference. So they might have a baby sit here, and then they present the baby with a female face and a male face, and they have little trackers on the computer that can track the baby's eyes, and they calculate how much time it takes them to look at the female versus the male face and which face they spend more time looking at. And usually what this research shows is that no matter the location of the face, so the female face could be here in one trial, male face could be here on one trial, and then they switch it so that the male face is here, the female face is here. Babies tend to prefer looking at female faces relative to male faces. It might be because they spend more time with a mom, breastfeeding and things like that. Cool. Does that make sense? Okay. Whew. All right, so what are some advantages of within groups designs? So one, participants in your groups are equivalent because they're the same participants and they serve as their own controls. So for example, some people in the study with chocolate might really like chocolate and others do not. So people in a repeated measures design, people bring their same level of affection for chocolate to both conditions. So their individual for the chocolate stays the same. So when you do random assignment for a between subjects design, you're hoping that you have enough people who like versus dislike chocolate in each condition. But within groups design, you don't have to worry about that because people serve as their own controls. These designs give researchers more power to determine differences between conditions. So power is when the ability of a study to show a statistically significant result, when an IV truly has an effect on the dependent variable. Since the same people are in your groups, it reduces unsystematic variability or noise between groups that may obscure two differences that exist. So you're eliminating any individual differences that might also predict the dependent variable. And within groups design require fewer participants than other designs. So if you were to have an independent groups design, you might need 20 people in condition 1 and 20 people in condition 2. So that's a total of 40 people. But in within groups design, you could have 20 people in condition 1 and then have them complete condition 2. So that halves your necessary participants.
Oh, okay.
Yeah. Okay, questions here. So Rick, why would you or wouldn't you use a within groups design for your study?
Oh.
Or what would a within
I'm
groups
lost.
design? Sorry?
That's what I'm trying to picture.
So
well,
for you,
just pre or one of the different times instead of both of them, or
they would
no.
be exposed to both levels of the IV. So you might have them do I want you to tell me your experiences pre-COVID, and then they rate their loneliness. And then you have their experiences during COVID, and they rate their loneliness. Why would you or wouldn't you want that?
Because you couldn't, there would be no comparison. You wouldn't see.
You do see
you
comparison.
couldn't match up. Well, only with themselves.
Yeah, but they serve as their own controls.
Yeah. I don't know. It got me.
That's okay. I just want to make sure y'all get, and Rick, I always put you under pressure. So thank you for always dealing with it. But
That's okay.
And
I
it's
thought
okay.
I had it. Then
yeah, and it's okay if you don't know. When I ask these questions, it is not to make you look bad. It's to like, for me to assess how much y'all understand it and how well I'm communicating it. So you can blame me. But anyway, okay. So in Rick's study,
explain then.
huh? What?
Oh, then it's up to you to explain it then.
Yeah, so now I'm going to explain it. So pre-COVID, and then they rate their level of loneliness, and then during COVID, and they rate their level of loneliness. One reason why you might not want to do it is because participants then will figure out what you're doing in your experiment. They're like, oh, this fool wants to see whether I'm more lonely during COVID versus before COVID. I want to be a good participant. I heard he needs grant money. So hell yeah, I'm going to say I'm more depressed during COVID than before COVID. Yeah, so your participants might guess. Yeah, your participants aren't dumb. They're going to guess whatever it is you're measuring. For this one, the way that they got away with it is that they told the participant that the chocolate was different. And that made them evaluate it differently. They didn't tell them how it was different. They didn't tell them that with the unshared experience, they would be getting bad chocolate, but they were just told that it was different. So that's one reason why within subjects design might not be good. Lacia, for your study, it wouldn't make sense because people might not be introverts and extroverts. So you can't make them, okay, so now you're going to be an introvert and I want you to evaluate your anxiety symptoms. Okay, now I want you to be an extrovert and rate your anxiety symptoms. Particularly when you have pre-existing groups, you can't make them go through both conditions. So one is the ethics, you can't make them go through both conditions, it doesn't make sense. And another one is that your participants are pretty smart and they will catch on to what you're doing. Haley, do you have a question?
I don't think so. You kind of
Okay.
answered it with.
Okay. Okay, cool. All right, so is that clear now that I made that example? Okay. So this is better. This is a better design for infants, for instance, because let's say that you only presented them with a female face first and you measured how much time they would spend looking at the face. Then you presented the male face next, and you measured how much time they spent looking at the male face. They might spend an equal amount of time looking at both faces because babies in general do like faces. Have y'all seen the, oh, okay, this is a cute thing. Okay, I'm gonna look it up because I do want, it is related, I swear. If my YouTube loads. Done. Well, I don't think I can, it's on TikTok. Yes, I'm on TikTok. Okay, so I can't find it, but essentially it's like, there's a dog and both the owners are there with a dog, right? So it's both the owners, so it could be two males, a male and a female, whatever. And what they do is that they run different directions because they want to see who the dog follows, right? So this is a good measure of that because it lets you know who the dog prefers, just like what face you look at lets you know what kind of face the baby prefers. If you just had one parent at a time, of course, the dog would follow the one parent. When they're forced into that decision with a concurrent measures design on TikTok, then you can see who the dog prefers. Have y'all seen that video? It's super cute. Okay, I'll try to find it and send it to y'all. Oh, okay, so now let's talk about covariance, temporal precedence, and internal validity in within groups designs. Okay, so I'm gonna let y'all choose. Do you want me to finish this lecture and then go into how to write a method and results section next week? Or do you want me to push this lecture to next week? There are about 10 slides left and go over methods and results section now. The benefit of going through method and results section now is that you can get a head start on writing your method and results section. Who wants to continue with this lecture? Okay, who wants to move on to method and results?
Need a control, we need a sample group.
Yeah. Yeah. Haley, what do you want?
When is the method and results due?
It's not due for a while.
Okay.
Yeah, so let me just double check. That's the worry. I think it's due in like 2 weeks. Let me just double check. 2 or 3 weeks. Yeah, I'm sorry. I don't have all of the due dates memorized.
That's okay.
Yeah. I have like,
Sorry, go ahead.
oh, no, sorry.
I briefly looked ahead, and is it the anticipated results or is it the actual results?
Anticipated results, because you don't have actual data.
Okay, because then I also had another question. Are we able to use the SONA study? I can't remember if it was already said, no, we have to find the participants on our own.
No, you don't need to. No. Okay, that's a great question. You are not running the study.
Okay.
That's why I'm calling it an anticipated results section.
Okay.
I'm going to make y'all write it as though your hypotheses were supported.
Well, that's very good.
Right?
That makes
Yeah.
a lot more sense and takes a lot of pressure off. Okay, I thought I had to go out and find a bunch of people and
no, you all would hate me because you have like a week to do that. And no.
I was
Okay.
thinking about where do I get a big hat?
Like, I'm not at school, so I can't like walk around and ask people to fill out a survey. So
No, you will have to do that for 467 and 468, but they take that into account by making them tandem classes, right? So you take 467 and 468, you collect the data, and then you analyze the data. So you learn how to do it across time, and you aren't like under pressure to collect all this data right away. So that's why I'm calling it an anticipated results section, because you won't actually have data. No, that's awful.
I looked at the syllabus and it says it's May 16th that that's
Oh yeah,
due.
you guys have a while. So that's
Yeah.
1, 2, like 2.5 weeks.
So I'm fine with just finishing this one.
Okay,
for
so
you.
let's
I don't care either way.
take another vote now that we know it's 2.5 weeks away. Who wants to talk about method and results now? Nobody. All right. Let's go through this. No, I just it's a lot. Like, I know it's a lot for y'all to take in, but whew, my mouth's getting dry. Hold on. Grace, did you have any more questions? Or anyone else have any more questions?
My notes stopped at unsystematic variability, so this is pretty.
We're just all processing.
Yeah.
This
You want me to
really
slow
helped.
down?
It helped. No, I mean, I had pre-notes already before class, and I could only get up to that point. But this, I'm matching my notes to what you're saying, and it really helps. It's like
Okay. I wasn't sure if you were like
it seeps
talking
in
ish.
really. No. It helps.
Okay. Okay, great. Am I talking too fast? Y'all want me to slow down? No? Okay. All right, so let's talk about covariance, temporal precedence, and internal validity and within groups designs. So do within groups design fulfill the 3 causal criteria? Again, we have covariance. There's a manipulated IV and comparison conditions. So yeah, it meets the covariance. There's a relationship between the IVs and the DVs. Temporal precedence. It does, because the IV typically comes before the dependent variable. Internal validity. Are there third variable explanations? So there are some third variable explanations, particularly when you're using within groups designs, and one of them is an order effect. So if you're tasting the chocolate alone, and then you taste the chocolate with a confederate, and then you rate it, the chocolate as being better when you taste it with a confederate relative to alone, it might be because you like the chocolate better across time. So maybe your palate gets desensitized to this awful tasting chocolate, and you just happen to like the chocolate more across time. So that's the third variable. So you might say, well, time is what predicts the increase in rating of chocolate. It's not necessarily the time spent with a confederate. But one way to avoid that is to counterbalance the presentation of your independent variable. So sometimes people taste the chocolate alone first, and other times people taste the chocolate with a confederate first. So that way you eliminate time as an explanation, because you are changing the order in which the chocolate is tasted, either alone or with someone else. Does that make sense? Yeah. So now the random assignment in within subjects design is randomly assign the order of the independent variables. So these are the independent variables. Rick, you look confused.
Oh,
Are you?
yeah, I'm trying to follow. I just got lost.
Okay. Haley, did it make sense? Do you want to give it a shot in explaining?
Yeah, what part specifically, or like all of it?
All of it.
Okay, so like the order effects part of it, I guess, is where it could be explained by what order you taste the chocolate in this example.
And
Professor
it is a
Stanhope
dependent
or-
variable. Sorry.
Yeah.
And it is a dependent variable. So you could potentially explain the differences in chocolate liking because of the order in which you present the independent variable. Sorry, go ahead.
Okay. Yeah. Okay. No, it's okay. But like Professor said that you could like the taste of chocolate more with time compared to if it's just like tasting it alone versus tasting it with the Confederate. And then you can avoid this by counterbalancing. So some people in your experiment taste it alone first and then with a Confederate after they rate it. Or some people taste it with a Confederate first and then rate it, and then taste it alone and then rate it again. And like in the book, it says like full counterbalancing versus partial counterbalancing as well. Would this be full because there's only two like portions of like what you would need to balance, I guess? Like
Yes.
all
Yeah.
of the orders of the condition are represented in like this.
Yeah, so counterbalancing is a lot easier when you only have 2 levels of an independent variable, but sometimes you have 10. So maybe you want to see whether they taste chocolate alone, taste the chocolate with someone they don't know, taste it with someone that they hate, taste it with one of their friends, taste it with their mom, taste it with their cousin, whatever. And that would be a lot harder to counterbalance because you have so many independent variables. So one of the ways that they talk about avoiding full counterbalancing is by using partial counterbalancing. And do I talk about that? I do not think I talk about that because that is, okay, I do talk about it. So we'll talk about that shortly. But we'll jump into that later. But does that make sense now, Rick?
Yeah, it's the same person.
Same person here, different person here.
Okay.
Yeah. But the order effects are just a threat to internal validity. So that's why you use counterbalancing to eliminate that.
Within the group.
Yes.
Okay.
Yes. All right. So, excuse me. We control for order effects because sometimes when being exposed to one condition affects how participants respond to the other condition. So give me a sec. So order effects are confounds within groups designs because it might not be the levels of the IV that cause the changes in the DV, but the order in which the conditions were experienced. So again, maybe it's the time that led people to like the chocolate more versus being alone or with someone else. There are different types of order effects. One is practice effect. This is when participants get better at a task from practice or get worse at a task due to fatigue, called the fatigue effect. So this is what I was talking about with the GRE. That might be an order effect if they take the GRE and then they go through some experimental manipulation and they take the GRE again. They might just get better because they know the questions. So that would be a practice effect. Or if you have people run a mile and then drink Gatorade and then run a mile again, they might do poorly because they are exhausted. So that would be a fatigue. That would be a fatigue effect. Another type of order effect is called a carryover effect. So this occurs when there's contamination carrying over from one condition to the next. So let's say that you drink caffeinated coffee and then take a test, and then you drink decaf and take a test. That might not be great because you still have the carryover, right? So the caffeine is still in your body. So you can't say like decaf coffee made you perform better on the test. It might still be the carryover effect from the original caffeinated cup of coffee. Does that make sense? Yeah, okay. All right, counterbalancing. This is what Haley was going through. All right, so there's full counterbalancing and partial counterbalancing. All right, so in order to avoid order effects, this is what researchers use. So full counterbalancing occurs when all possible condition orders are presented. For example, with 2 conditions, there are 2 orders. With 3 conditions, there are 6 orders, and so on and so forth. So as soon as you go beyond 3 conditions, I mean, yeah, three conditions, the orders just magnify, right? And they multiply very quickly. So with 3 conditions, there are 6 orders. So you would want people, let's say you want 60 people. So you would want 10 people per each order. But that's already using up a lot of your sample. So after that, we tend to use partial counterbalancing after you have 3 conditions, because it just is so time intensive and you have so many people that you need to put in through each condition. So that occurs when only some of the possible conditions are used. For example, a researcher could present a randomized order for each participant or a Latin square. So each condition appears in each position at least once. So you don't have tasting chocolate and alone and then with someone else, and then eating it with someone else versus alone. So you would have just some people who are exposed to one condition and some people that are exposed to the other condition, such that there's at least one person within each of the conditions. So let's say this was the 3 condition and 6 orders. You would try to have at least one person within each of the orders, so that that's represented. That would be partial counterbalancing, just because it takes so many people. Does that make sense? Rick.
Yeah.
It is very complicated. We typically do not. I've never used it, but some researchers do use it. Haley or Rick, do you have a question? No. Okay. All right. So what are some disadvantages of within groups designs? So again, there's the potential for order effects, but we can stop that with counterbalancing. It might not be practical or possible. So suppose someone has devised a new way of teaching children how to ride a bike called method A. She wants to compare method A with an older method, method B. She can't teach a group of children to ride a bike with method A and then return them to baseline, not knowing how to ride a bike, and then teach them method B. So once taught, the children are permanently changed. In such a case, a within groups design with or without counterbalancing would make really no sense. And the third disadvantage is that experiencing all levels of the independent variable changes the way that participants act. So there's demand characteristics. This is sort of what I was talking about with Rick's study. So if they know that they're going to be measured with on loneliness, and they were asked questions before COVID and then during COVID, they're going to be like, well, I know that he wants to measure my degree of loneliness, and he's probably hypothesizing that I'm more lonely during COVID than before COVID, so let me just pretend to be more lonely. So demand characteristics occur when participants pick up on cues that lead them to guess the experiment's hypothesis. And most people want to be good participants, so they try to go along with your hypotheses, but sometimes you have rebels who want to destroy your research career, so they just go completely against your hypotheses. All right, so question, is the pre-test, post-test a repeated measures design? No, Haley, why not?
Because of the, like, you in one, okay, so in the pre-test you get like shown like the dependent variable first, and then like the independent variable is measured, and then you do like the post-test the dependent variable again. But in a repeated measure, it's like flipped.
Yes.
So you get like the IVs measured first, and then the DV, and then the IV, and then the DV.
That's one difference. In a pre-test, post-test design, you're measuring the dependent variable before exposure to the independent variable and after. Whereas here, this is exactly what Haley said. First, you get exposed to one level of the independent variable, you measure the DV, and then the second level of the independent variable in the DV. So difference is presentation of the DVs, and 2, exposure to the independent variables. So in a pre-test, post-test design, people are exposed to either one of the 2 conditions. So you either get level A or level B. And within a repeated measures design, you're exposed to all levels of the independent variable. So you're exposed to level A and level B. So those are the 2 differences. So a pre-test, post-test design is not the same as a repeated measures design. So pre-test, post-test design is a between subjects or independent subjects design, because those who are exposed to level A are independent from those that are exposed to level B. Whereas a repeated measures design is a within subjects design, because participant one's exposure to level A is compared to participant one's exposure to level B. Does that make sense, Alicia and Rick and Haley?
Yeah.
Okay. Oh, okay. It's a lot. I feel like I've gone through a lot, like just with like experiments versus not experiments, but it's okay. We'll keep going. All right. Do y'all feel like it's a lot?
Yeah, it's all right.
Yeah, it is a lot. So interrogating causal claims of the 4 validities. Again, they keep coming up: construct, external, statistical, and internal validity. So construct, how well were the variables measured? External, to whom or what can the causal claims generalize? Statistical, how well do the data support the causal claim? And internal, are there alternative explanations for the outcome? Let's go with construct first. So how well were the variables measured or manipulated? So for the dependent variable, you ask how well were they measured? So this could be for used on the laptop versus longhand note study. So you could start by asking how well the researchers measured their dependent variables, factual versus conceptual knowledge. So they provided examples of factual and conceptual questions they used. So you could examine them and evaluate if they actually do constitute good measures of factual learning. So what is the purpose of adding calcium propionate to bread and conceptual learning? If a person's epiglottis was not working properly, what would be likely to happen? Those are examples of factual and conceptual questions. And these 2 examples do seem like appropriate types of questions, because the first asked for direct recall of a lecture's actual or factual information, and the second one requires people to understand the epiglottis and make an inference. Then independent variables, how well were they manipulated? So you can ask how well the researchers manipulated or operationalized them. So in the Mueller and Oppenheimer study, this was straightforward. People were given either a pen or a laptop. So the operationalization was clearly manipulated with an intended variable. But another way to check is with a manipulation check. So this is an extra dependent variable that researchers can insert into an experiment to convince them that their experimental manipulation worked. This wasn't necessary in the note-taking study, because research assistants could simply observe participants and see whether they were writing on a laptop or writing with a pen. But I can give you an example. So I'm running a study right now where I'm looking at whether perceptions of fairness vary as a function of increasing diversity in the United States. So in condition 1, I have people read about the Census Bureau information that by 2050, racial and ethnic minorities will become the majority. Or they're assigned to a condition where they read about, what is it called? Not social mobility, but residential mobility. So by 2050, a lot more people are going to move across the country or to different states because of the increase in rent, and so on and so forth. So my manipulation is either diversity, increasing diversity, or increasing geographic mobility. So they have to read this thing. So it's all online. They have to read like a paragraph, and then they complete my dependent measures. But sometimes, and I'm paying people to do this, so sometimes people don't actually read the paragraph and they just complete the dependent measures, which means that my dependent measures are kind of trash. So one way that I make sure that they actually read it is that towards the end of the study, I'm like, what was the article you read about? Do you recall what year the article was talking about? So just ask them general questions about the article that they read. And then the final question is like, did you read about geographic mobility, ballerinas, or diversity? So I'm trying to give people a chance to let me know that they read the article or not. So that's a manipulation check. So did I actually manipulate their beliefs about diversity or geographic mobility? Because otherwise my data would be trash if I didn't have a manipulation check. If I didn't have a difference between the groups, I would say, well, maybe my study sucks. But if then I go and check and people don't actually read the articles, then my study might not suck. Maybe it's the participants. So I need to rerun the study. We also have pilot studies. So this is using a separate group of participants that is completed either before or sometimes after conducting the study. So researchers may use pilot study data to confirm the effectiveness of their manipulations before using them in a target study. So before using these articles, other researchers have created these articles, and what they did is they just had undergraduates read each article and then describe what the article was about. And it seemed like the increasing diversity article did communicate increasing diversity, and the increasing geographic mobility article did communicate increasing geographic mobility. So in that way, we know that our independent variable is actually manipulating what we want it to manipulate. Does that make sense? Okay. Construct validity and theory testing. All right, so in the Mueller and Oppenheimer study, remember that they proposed that laptop note-taking would let students more easily take notes compared to taking handwritten notes. So they would take more verbatim notes. In fact, their study included measures of verbatim overlap so they could test their theory. After transcribing each person's notes, they measured how closely the notes overlapped verbatim with a video lecture. However, it turned out that the people in the laptop condition had in fact written more verbatim notes than people in the longhand condition. In addition, the more people wrote verbatim notes, the worse that they did on the essay test. So the researchers supported their theory by measuring key constructs that their theory proposed. So their theory was that although people that are writing on laptops actually write more notes and copy words verbatim, they perform poorly on the test. So they measured how many words verbatim people with longhand versus laptop notes took. Does that make sense? So that was their theory. So they tested it. All right, external validity. To whom or what can the causal claim generalize? So generalizing to other people. How are the participants selected in the study that we've been talking about? Was random sampling used? So in the Mueller and Oppenheimer study, the 67 students were a convenience sample rather than a random sample of undergraduates from Princeton University. And this is what most research is. Most research uses convenience sampling. Because they were a convenience sample, you can't be sure if the results would generalize to all Princeton University students, not to mention all college students in general. In addition, because the study was only run on college students, you can't assume that the results would apply to middle or high school students. And you might not be able to generalize to other situations. So the note-taking study used 5 videotaped TED Talk lectures. In their published article, Mueller and Oppenheimer reported 2 additional experiments, each of which used new video lectures. All three experiments found the same pattern. So you can infer that the laptop note-taking does generalize to other TED Talks. You can't be sure from the study if laptop note-taking would generalize to a live lecture class. You also don't know if this would happen in people's major classes because maybe they pay more attention in their actual major classes. You also don't know if the effect of laptop note-taking would generalize to other kinds of college teaching, such as team-based learning or lab courses. So what if external validity is poor? So what if you can't really generalize your findings to other situations or other people? So the validity that is emphasized the most in an experiment is internal validity. So how much experimental control you have, how likely it is that you can say that your independent variable manipulation of it led to changes in the dependent variable. So in order to achieve experimental control, researchers must sometimes conduct their studies in artificial laboratory environments that might not represent the real world. So I'm having these people read about this article about increasing diversity or geographic mobility, which might be very different than living in a residential area with a lot of geographic mobility or actual diverse people. So a lot of our experiments in psychology have really poor external validity. So many experiments sacrifice real world representativeness in exchange for internal validity. So testing our theory and teasing out the causal variable from potential confounds were the steps for Mueller and Oppenheimer. In addition, running an experiment on a relatively homogeneous sample, such as college students, meant that the unsystematic variability was less likely to obscure the finding of the independent variable. So this is just letting you know like some of the weaknesses of empirical work in psychology. We can't always have really good external validity, and external validity tends to be inversely related to internal validity, because the more we try to control to make sure that we can say that the changes in the independent variable led to, or the manipulation of the independent variable led to changes in the dependent variable, the less we're able to generalize to the real world, because in the real world, we don't have all of these different controls, right? So prejudice exists when people are hungry or when people are tired or so on and so forth. And their prejudice scores might vary throughout the day, which is not something that we try to do in an experiment. Does that make sense? That was a lot of reading. Okay. How well do the data support the causal claim? So again, statistical validity. So is the difference statistically significant? Is the difference between the means obtained in the experiment statistically significant? Are you sure that the results didn't occur by chance? How large is the effect? So those are the kind of questions you ask when it comes to statistical validity. Effect size can help determine covariance, which is the first step in causal claims. So typically the larger the effect size, the stronger the causal effect. So we talk about Cohen's d. We already talked about Cohen's d. Effect size 0.2, 0.5, 0.8 corresponds to either a small, medium, or large effect size. And we look at the differences between group 1 and group 2, group 1 and group 2. So this is just measuring whether your results were statistically significant and the strength of your effect with statistical validity. All right, and what about internal validity? So this is how well you can say, or how strongly you can claim that your changes in the dependent variable were due to your manipulations of the independent variable. So these are the questions that you ask when you're talking about internal validity. Were there any design confounds? Did I accidentally put more Coke people in the during COVID condition relative to the pre-COVID condition? So for the Mueller and Oppenheimer study, they made sure people in both groups saw the same video lectures in the same room with the same temperature and so on. Number 2, if an independent group's design was used, did researchers control for selection effects using random assignment or matching? Did you use random assignments or matching? Did you also measure any independent variables that could potentially change the effect of your dependent variable? So if you use random assignment, that could control for selection effects in the note-taking study, because you might have had students who were like, oh, I like taking notes by hand versus I like taking notes via my computer. And that could have affected the results of the study. Yeah, if a within groups design was used, did the researchers control for order effects by counterbalancing? So we already talked about that. Counterbalancing wasn't relevant for the Mueller study because it was an independent group's design. Remember, they either did the laptop or the longhand design. Okay. So we learned a lot about experiments. We learned what an experiment was. And this sort of answers Grace's question. You won't have any data to report in your anticipated results sections. I want you to report the results as though your hypotheses were supported. I just want to go through this really quickly right now, and then I'll go through it more deeply on Monday. So from current slide. So I have these stats cheat sheets and how to write up results. And we'll look at that on Monday. So I used 2 people's studies, but this is essentially what most of you all will be doing if there are 2 levels of one independent variable. Haley, I think you're going to run a different test because you have 2 independent variables with 2 levels each. So I'll also include that in this lecture. But for Rick and for Alicia, an independent samples t-test was conducted to examine the effects of whatever your IV is on whatever your DV is. Results showed that those in condition 1 scored higher or lower on the dependent variable than those in condition 2. And then you can just make up some numbers to put in here. So an independent samples t-test was conducted to examine the effects of the time of report on loneliness scores. And you could remove IV and DV. I just kept that there so you know what I'm talking about. Consistent with hypotheses, results showed that those in the pre-COVID condition scored lower on the UCLA loneliness scale than those in the COVID condition. That's generally what your results section will look like. Rick. Yes, Haley.
I I'm still seeing like the internal validity slide. Are you on a different slide?
Oh yeah, my bad.
I was
Oh,
like, is that just
sorry.
me or is that everyone?
No, I am.
Sorry, I didn't
Google.
say.
Okay, so this is the stats. Can you see this now?
Yes.
Oh my God, I am so sorry.
It's okay.
Stats cheat sheet. So this
No
is,
one said
so
anything.
this you can essentially copy and paste into your paper. Except you, Haley, we will talk about the NOVA next class. So then I just put the time of report on loneliness scores consistent with the hypotheses, blah, blah, blah. That's essentially what your results section will kind of look like, Rick.
Excellent.
And then I did it for independent samples t-test was conducted to examine the effects of extroversion on anxiety symptomology. Consistent with hypotheses, results showed that extroverts scored lower on the physical component of the anxiety symptomology scale than introverts. And you don't have to include this IV and DV. I just included that because I just wanted to make it clear. I also color coded it. And that's mostly my anticipated results section, but again, we'll go through it more deeply on Monday. I do have a stats cheat sheet. So let me just open this. And let me make sure to share that with you so that I'm not just, okay. Let's see. Okay. Okay, so if you have one variable, one independent variable, you're going to do either an independent samples t-test or a paired samples t-test. If people only go through one of the two conditions, it's going to be an independent samples t-test. That's what most of you will be doing. If you have more than one variable, this is Haley. It is going to be it's going to be under here. You're not going to do a linear regression. We don't need that. You're not going to do a Mancova. You're not going to do a mixed designs because you don't have between and within subjects. You're not going to do a factorial. You're going to do a one-way MANOVA or ANOVA. And we'll talk about what that means. But this is just sort of a good little cheat sheet to see what kind of analysis you'll have to run. Cool. Any questions? Okay, so this is already up on our website or on our Canvas site. If you
Okay.
want to also look at the method section, I already included that, but we'll talk about it on Monday. So I talk about all the things, and then I included a sample paper so that you can use. And that's it for today. That was, yeah, I was too ambitious with all the things I wanted to cover. But can you see the PowerPoint that I'm sharing now? The method? Okay. Okay.
Yes.
That one's a lot more plain. The results section is a lot more exciting. I like the little background here. But both of these PowerPoints, including the PowerPoint that I talked about today, are already on our Canvas page. Remember to turn in the assignments that are due this week and look at the methods and results if you want, and you can get started. And I know it was a lot today, so go take a nap or something if you can. A lot of cognitive depletion.